In this lecture, I am going to discuss about an important concept in Python language that is called classes and objects. As you may know, Python is an object-oriented programming language, or in short, OOP language, which means all the variables and the functions that we have used are part of some classes, and while declaring one variable, what we are essentially doing is we are creating some object of those classes. Now, as you may know, Python is an object oriented programming language, or in short OOP language, which means all the variables that we have declared are some objects of some defined classes which are defined inside Python, and all the functions that we have used, those functions are defined as part of those classes as well. While writing our code so far, we have encountered two broad type of data types, which is first is called simple data type and the other is called compound data type. In particular, integer, float, complex or strings are simple data types. In comparison, list, set, tuples and dictionaries are compound data types. To check the type of a defined variable, we have seen that there is a function called type, in which if we provide the name of the variable, it should be returning the data type. For example, if I want to know the data type of this variable I need to provide type in bracket I, and that should have been returning some output like this. Now, as you can see here, the output would have been class int, or in case it is a dictionary, for example this one where key and values are given, if I print the type of the variable here, it will return class dict. While writing our past codes to check the data type of a defined variable, we have come across this term class, and in Python all data types are some classes which is defined in Python, and every time we declare a variable of some type, an object of the corresponding class is actually created in the memory. Formally, an object is a collection of data or variables and a set of methods or functions that act on those data, and classes are formally the blueprint of that object. The classes associated with the variables that we have used so far, like int, float, complex, string or list, set, dictionary, etc., are defined in Python by the Python developer. Note that these variables and functions will be declared or defined in these classes, and to use those variables and functions, what we need to do is we need to create some object of those classes. For example, to create a car, we need some blueprint on how the car will be functioning, like how the door will be opened, how the music will be played in a car, and those details will be defined in a class. And to actually create a car, we will need to create one object of that class type, and using that object we will be able to use these variables and functions that are defined in this class car. Now, to define a class, there is a designated keyword called class, and the class definition should be beginning with that keyword. The first component inside a class is a string which is called docstring, or in full form documentation string, and it contains a brief description about the work that the class is written for. This is a sample definition of a class, where as you can see, the name of the class is my new class. It is preceding by a keyword class, and here this is the doc string or documentation string, and the rest of the class content will be following that doc string part. Other than the doc string, a class may contain two other parts. One is class variable and another is class functions. Note that all these three components are optional. That is, you may find a class without having a doc string, you may find a class without having a class variable, or you may also find a class without having any defined function. This is an example of a class. The name of the class is person, and here it is the doc string associated with this class, which is containing the text "this is a person" class. As I have stated earlier, there can be two other components in a class. One is variable and another is function. Here in this example, age is a variable of this class, and here greet is a function attribute of the same class, that is called person. Also notice the indentation here. Here this is the body of the class. It is containing the doc string, a variable which is called age, a function which is called greet, and all these three components of the class are right indented after the colon, which is given just after the name of the class. Here I have written the same class person here, and to access this age, what we have to do is we have to invoke the variable age with the name of the class. Now if I execute this, we'll be able to get the value that is stored in this age variable, which is defined inside this class person. Also, there are certain special attributes that are defined implicitly while we are defining the class. One of them is called the __doc__, which is basically pointing to the doc string, that is what is the purpose for which this class has been written. Here, if I want to get the doc string, I can access using that __doc__ special attribute. As you can see, this is actually printing the doc string of the class. There is another special attribute which we can also use. It's called the name special attribute, which will be printing the name of the class. Now to instantiate a new object of a class, we need to follow this kind of notation. So here P will be the variable or object of this class, which is called person. Now using that object, we will also be able to access the corresponding attributes in a class. So for example, if I want to access the age attribute, what we need to do is we first of all need to instantiate this object, and then that object dot the attribute name, we will be able to access the corresponding value that is stored in the attribute. In the same way, we will be able to access the function attributes as well. So here I am invoking this greet function, which is defined in this person class, and I am actually invoking the function through this instantiation of this class, which is an object that is called P, and P dot the name of the function is actually invoking that function. So summarizing the concept, a class creates a new local namespace in which all the attributes will be defined. By attribute, I am referring to the variables and the functions. There are special types of attributes which are defined implicitly when we are defining the class. Those are starting with a double underscore and ending with another double underscore. For example, as we have seen, __doc__ will be returning the doc string, or __name__ will be returning the name of the class. As soon as we define a class, a new class object is implicitly created with the same name. In this example, the person here is an object which is created implicitly when we are defining the class, which is called the person. And using this class object, we will be able to declare new objects, or we will be able to instantiate new object of that class. Now let's look at the program, particularly the function attribute once again. Here, while defining the function, as you can see, I have specified one parameter which is called self here. but while calling that function I am not passing any parameters. Now this statement is equivalent to calling the greet function in this way. Here I am using the same object that has been created while we define the class person, and we are passing the implicitly defined or implicitly instantiated object name, and this object called p, small p, is getting passed here to this function greet as the parameter self. If we want to define a function in a class, then it should be having one extra first parameter. For example, if we want to define a function which should be taking two parameters for its computation, then formally while defining the function there should be three parameters defined here, and the first parameter should always be this self, which refers to the invoking object as I have shown here with this p. And while calling the function, we need not provide any parameter values for this self. And if we have a method or if we have a function which does not take any argument, still we will have to pass this self parameter while defining the function. There is another special attribute which is a method attribute that is called the init function. This init function is equivalent to the constructors that we might have seen while writing our C++ or Java programs. I have defined the same person class here. As you can see, this init or this constructor function is expecting from me one parameter which is considered as a name. Note that self is again the implicitly passed parameter which is the invoking object. Now to create one object of this person class, what we need to do is we need to provide one parameter, because as I have said, this constructor special function, special attribute is expecting one parameter. So if I provide one name here, you can see this function is getting called implicitly when we are actually defining one object of this class, and using this init, this name which is a parameter, which is an attribute of this class, is getting initialized. Now to make sure that this function is actually getting called, we can put one print statement here, and now if I call this, as you can see here in init, this message is getting printed because this function is getting called when we are creating the object of this class. Now if I want to call this greet function, we'll be able to see one very nice output. So to call this greet function, what we need to do is we need to invoke this greet function using the object that I have defined earlier. Now note that this greet, while defining, I have specified only one parameter which is self. So while calling, I should not be providing any parameter, and this self is basically the invoking parameter, that is p here. So p is basically transferred here as self, and if I execute this, as you can understand, this self dot name will be the name that I have used to initialize this object with while creating this object. So if I execute this, you'll be able to see hello Alice is getting printed from this greet function. Now those of you who have some experience writing codes in Java, you can see that there is a similarity between this init method and the constructor that we have used in Java. For Java, we needed to pass the parameter that we want to actually initialize some variable here. In this case it's called n, which is of the same type string, and the name of the constructor was exactly the same as the name of the class. And while creating one object of this class, this constructor would have been called implicitly. Similar to here in Python, this init function will also be getting called implicitly whenever we will be creating one object of this class. Now to summarize the concept, to create one object of a class, we should be following this kind of notation. So this will be creating one new object, and the name of the object will be P, and using this P we will be able to access all the attributes that are defined in this person class. Now these attributes can be variables as well as method. In this case, this is a method that we are calling using this P object. As another example, here I am creating one object of string class as we have done earlier. The string S was containing this string, and these two functions, which I hope you have already used, these two functions, upper and split, are actually defined in the string class, which is defined by the Python developer. Now look at another example. Here I am defining a class called person, which is containing one class variable attribute that is called species, that is initialized with the string mammal. It contains another init attribute, which is a special attribute. Using this init attribute, I want to initialize the name and age of some species having the type mammal. Now I have written the same code here. Now if I want to create one object of this person, say called Alice, with the two parameters, that is called, first will be name Alice and then the second will be age, say 23. So this will actually be calling this init function, and to access the name and age, which are the attributes of this person class, we can call these, or we can access these using the object by this membership operator, which is called dot. So alice.name will be printing the value that is stored as name in Alice, in this Alice object. And if I want to access the age, so alice.age, which is actually 23, if I execute this, it will be printing the value that is stored in this age parameter, age attribute of this object Alice. We will also be able to access this species parameter as well. So print Alice dot species, it will be printing the value mammal here. Now let's define another class here. Here the name of the class is complex number, which is containing one attribute function that is called getData, and another special attribute, the same init or the constructor, which is containing two parameters, r and I. Note that the value of r and I are initialized to 0 and 0. So if I create one object of this complex number class, and if we do not provide any parameter, so this r and I, the default value would be considered, that will be 0. Here I have the same example written. So if I create one object, say num equals to complex number, and if I execute, as you can see, there is no immediate output. But if I call this num, this getData function using this num, you can see the default value is considered, which is 0 and 0. That's why I am getting this output as 0 plus 0j. So it's basically a plus bj or something like that. Now to dissect this statement here in line number 1, which is num equals to complex number, is calling this function, this init special attribute, and as we are not passing any parameter, the default values of these r and I parameters are considered, and this real and image two variable attributes of this function is initialized with that value of r and I. Now if I create another object, say num2 with the parameters say 2 comma 3 and call the getData method, we'll be able to see that these 2 and 3 is overwriting the default value 0 and 0 here. So this 2, the r has become 2 here, the I has become 3 here. So these r and I, basically 2 and 3, are actually initializing this real and image of this invoking object, and whenever I am calling this function getData, that corresponding values of real and image are getting printed. As you can guess, another way of accessing this real and image part will be directly using the membership operator. Say num2 dot real and num2 dot image will be printing the value 2 and 3, which we have used to initialize this num2 object. Now as an exercise, I want you to write a function in this complex number class that would take two objects of this complex number class and will be adding them and will be returning the result. If you try it out for yourself, pause the video and try it out and then play this video again to see how I have written the code. Now let's write the add function. So I'm calling the function as add. As I have said earlier, the first parameter should be the self, and then let's define another parameter as num. Now let's define another object of this complex number class. Let's call it say res, which will be containing the resulting complex number. And note that this self is the invoking object and num would be the second object. So if I want to, if there are two complex number a and b, then if I invoke this add function with a, so in that case self will be a and the num will be b. I'll be writing the entire code here, which will make this whole concept clear. So res dot real will be self dot real plus num dot real, and res dot imaginary image equals to self dot image plus num dot image, and as a returning value I want to return this res. So what I am doing here is I am taking one parameter, and which is I am considering this as another complex number, and here I am defining one object of the same class which I am referring to as res, and then res dot real is equals to self, which is the invoking parameter, self dot real plus the second parameter dot real. Similarly, res dot image equals to self dot image plus num dot image, and finally I am returning the result. Now let's declare two complex numbers. Complex numbers say 2 comma 3, which is basically 2 plus 3j, and declare another complex number num2 as say 4 comma say minus 6. So this complex number is basically 2 plus 3j or 3i, and here this complex number is 4 minus 6j. Now if I execute this, you can see there is no immediate output. I can print the individual num1 and num2 if I call the corresponding getData function. Now let's call this add function. So num1 dot add and I need to pass another parameter. In this case I am passing the parameter num2 here. So this will be calling this function add. Self will be num1, which is 2 plus 3j, and this num will be num2, which will be 4 minus 6j. And here I will be computing the sum of those two complex numbers, and I will be returning the resulting complex number object. Now, as it is returning a value, I should be taking the value in some variable. Let's declare another variable, say r, which will be again another object of this complex number class. And if I execute this, after execution of this, as you can see, it has been executed. Now if I call the get data function, which will be printing the value in r, we'll be getting that the output is 4 plus 2, which is 6, and 3 minus 6, which is minus 3j. Now note that here in this function, when I have defined get data, I have explicitly mentioned this as plus. So that's why this output is plus minus 3j. Based on the sign of this imaginary part, I hope you will be able to change this get data function, which will be considering the exact sign which will be in between this real and image. Now as an exercise, I would like to ask you to write one class called location that would contain the latitude and the longitude of a position in the Earth surface, and as a part of the attribute, the function attribute of this location class, write a function called distance that would compute the distance between any two location objects of this location class using the Haversine distance.